Hello, everyone. I am Andreas. I'm a founding engineer at Connectly, and I'm here to talk to you a little bit about how to approach your code base management. So a bit extending, I guess, on the topic of the previous speaker, but going a little bit higher. So we're going to talk a little bit about how to view the code base in its entirety. So we're not going to be talking specifically about microservices or in specific architecture, but how to structure the code base so that you have maximum flexibility and you can adapt to changing conditions of the business needs and the engineering needs. I want to remind everybody to please use the Q&A tab if you have any questions, and I'll try to get through them at the end of the talk. So usually in the beginning, when we start with a code base, we start with a basic monolith, a single library if you want. And there are many tutorials out there on YouTube that allow you to do that. Usually that's called some version of the app, depending of which specific language are you using. That's where we put all our code. And then we, as a startup, like even as when we started at Connectly, like we were trying to code everything in there in order to move faster and find some product market fit. But the reality is that the technology is a very dynamic environment, and the market is always moving. So you could say that the only real constant in technology industry is the perpetual change. And the truth is that no plan survives first contact with the customer. So all startups need to be able to pivot really, really fast. For Connectly, for example, that meant that we started with the goal to become an AI-enhanced multi-channel messaging platform for customer support. But in 2022 now, we have pivoted to being an AI-powered end-to-end conversational commerce experience in WhatsApp. So that's a nice investor line, you might say, Andreas, but what does it actually mean? So for engineers, I like to follow this this model is I call it TKA. So what are we going to keep? What are we going to throw? And what are we going to add in order to execute our pivot? So we started with a messaging system where we're going to keep that, but we're going to focus now on the WhatsApp platform. We're going to throw away the ticketing system and the agent management because we're not doing customer support now. And we're going to add a lot of commerce integrations, for example, API integrations to Shopify. But because we had a flexible code base and commerce integrations are more or less another type of API integration, and we had already built multi-channel support for API integrations to support multiple messaging platforms, we were able to execute a full pivot of the company in about 3 months instead of the usual 6. Even though if you find the product market fit and you start scaling your code base, the product requirements start ballooning and becoming a lot more diverse. So you have to build auxiliary functions like payments, customer support, native customer support. You have to support A/B testing in order to test out different variants of your product to optimize that and see which one brings better conversions. And you might start considering expanding to more product categories. For example, when I worked at Uber started with a black car. But when we expanded there, when I got there, Uber was involved with a lot of different product categories like food deliveries, bike rentals, parcel deliveries, bus tickets, and much more. So the list of features is ever growing. So at some point you're going to wake up and find a dependency graph such as this. And at that you have 2 options. Either you declare bankruptcy, and this is the point where you actually see a lot of the early engineers leaving up for new greener pastures, or you're going to start adding some structure. And a lot of the structure that you see is at the system level, going from a monolith to tiered services. And on the backend services, you see going from a multi-repo usually to some sort of a layered monorepo to scale the tooling infrastructure. And on the front end, you might see going from a single app into micro front ends. And I think there's a talk tomorrow about micro front ends as well. But even when you are in a pretty big company, there are other concerns to consider when looking at your code base, which is just the plain fact that your code actually runs in many more environments than one, right? So it runs within unit tests where you only run one class and file with a unit testing framework, which in a lot of systems is an entirely different runtime. For example, in Android testing, it's an entirely different VM. You might have component tests which run in your CI environment, and that's a completely different host as well. You might have integration tests where you run the code in a similar environment, but with many different dependencies mocked. Or you might even have a full canary or dev environment where you run end-to-end tests before you deploy with real hosts and just different configurations. This becomes especially interesting if you have integrations, because you need to manage also the dev account. And then finally, hopefully you get to prod, which is the code that runs that the actual customers are looking at that. So with all that in mind, like, is it enough to just have one app directory? I'm going to argue that following this high-level structure of these 4 layers, apps, features, SDKs, and tenants, is going to give you a lot more flexibility. It's going to allow you to adapt into these different scenarios. Let's take a look at what each of these means. So what are the tenants? So I consider the code base as the technology company basic religion. So if that's the case, then the tenant libraries are the core beliefs of the religion. So that basically means tenants are the fundamental building blocks on which your entire code base depends on. The way you classify tenants usually is you say, hey, what does all my code need to do? Or what is something that my entire system needs to do? When you build tenants, essentially you build technical capabilities into the system, which means that something that your system was not able to do before, now it has the ability to do it. What does that look like at the system level? That usually is where the infrastructure comes in. So usually you need some storage service in order to store data. You might have more requirements depending on what the access pattern of those data is. So you might have RDS for transactional data, or NoSQL or S3 for long-term storage. You might have compute resources like EC2 and Lambda. You might have queues and pub-sub mechanics like RabbitMQ and Kafka. You might have caching layers. And I would also add the data schema decisions to this point, which is how you manage and evolve your data model. So, for example, at Connectly, we use protobuf for that and migrations. At the backend, we prefer to separate our code into these tenant packages, which have which provide some general capability to the entire code base. So a request library might allow you to do a network request, right? The stream library might allow you to register to a Kafka stream. An analytics library will allow your code to register analytics to your analytics pipeline. Configuration management for your applications, or logging or performance logging, or other generic utilities like time utilities, or depending on what the specific domain of your company is. The basic breakdown of such a package usually separates the API from the implementation. And then you might add some fake implementations for unit testing, then the tests of the package themselves. Some very common examples here might be communication tenants like networking. So how do I communicate with downstream services? Is it REST connections? Is it gRPC? Some service discovery tenants are pretty common. How do I know where the downstream active services are located? Am I using sidecars in my configurations or not? And then how do I perform basic CRUD operations to the storage? Do I use an ORM or not? A lot of the open source libraries that you see here could form into the tenants category. And you should do well to look whether there is something out there in the open source community that can help you do that. Other pretty common tenets are around observability, so gathering analytics and allowing the business to understand how the business metrics are doing, logging and monitoring our services for reliability and our system for reliability. Do I have enough information to troubleshoot and debug? Adding capabilities to your logging library to troubleshoot issues is super important, especially in the beginning. And then as you grow more and performance becomes more and more important and you're trying to scale your system, capturing performance metrics is also pretty important. Configuration, configuring your services based on the environment that you're running is also pretty important. Is it static configuration? So is it configuration files? Is it dynamic configuration that relies on maybe some Redis cache or something like that? Localization and geolocation-based experiments is a pretty common use of that. And then finally, as you grow, you want to consider some experimentation tenets to allow you to create A/B variants of your product so that you can optimize those for conversion. And finally, testing, also pretty common tenets. You want to make sure that everybody who runs, let's say, your Golang database, your Golang code, tests the Golang code in the same manner. That would include the test utilities using a common unit test library, integration test library, as well as common matchers based on your environment for that. Other pretty common test utilities is very useful to randomize the inputs to make sure that the tests are actually testing what you want them to. On the front end, tenants look usually similar to the back end. So network request, analytics, logging, etc. You might consider using GraphQL here as well, which is pretty common front end, back end API. And you also have to deal with front end specific things like a UI design system, how to do themes and styling consistently across different apps, and how you standardize components across different applications as well from the same company. And last but not least, obviously, navigation. So how do you move from one feature to the other is also pretty critical since your entire application structure usually depends on that. In the end, tenants should be very reusable, highly reusable, should not depend on the specific domain of the company. So if your company starts going under, you can always copy the tenants directory and start a new company in a different domain. Moving on to the SDKs. SDKs is basically where the core of the company's intellectual property is located. It basically represents the extent of the accumulated domain knowledge in the company. Some things that you should consider when deciding when and where to build an SDK is to identify reusable workflows that are used across multiple products. Usually things that go in SDKs is something that more than one of your applications need to use or your services. And in general, SDKs follow a plugin architecture, so they don't assume a specific context, but provide APIs so that they can be customized depending on whether in which service they're running. For example, an authentication middleware might have a whitelist and a blacklist, right? And the whitelist and the blacklist would be provided as a configuration into the SDK. From the application context. When you're thinking about building new SDKs, you usually should be thinking about building product or business capabilities and expand the ability of the product people essentially to define new products in your product lines. At the system level, that looks like core business flows. For example, in the Connectly case, we had messages and tickets, right? That was core business flows. The messaging system we could reuse in our pivot. The ticketing system we would have to be deprecated. In the Uber system, for example, you could have orders and payments, and those could be used both for Uber rides as well as bike rentals or bus tickets. And the payment infrastructure could also be reused across different product lines. Other things you should consider here in terms of capabilities is to build product infrastructure. So basically more high-level concepts than the low-level infra we looked at previously. A pretty common thing here is a long-term workflow system. Some of the patterns that you saw in the previous talk, for example, with microservices, could be captured here in order to standardize those. Implementing the ability to send push notifications to clients, also pretty important, or implementing third-party API gateways so that you can integrate, let's say, the WhatsApp API or the Shopify API in different product lines would also belong here. At the backend repository, that might look something like an SDKs folder with different types of libraries underneath that. For example, I mentioned the authentication middleware as an example that can be used across multiple services. The payments infrastructure could be exposed as a common SDK that different services can reuse. If you use model generation with protobuf, then your data models are going to belong here too. Ticketing system infrastructure, or even more specialized domain knowledge like domain models. For example, if you have an entity recognition model, that can belong here as well. Typically, the structure of the backend packages follows the same general structure as the tenants packages, but you also, since you now deal a lot with domain models too, you also add some fixtures, which is standardized domain models that specify kind of like some specific states of the system so that you can use that in testing. And then if you have standardized integrations, then you might also see an integration package which explicitly customizes a more general SDK to a specific use case. Might be, let's say, for customers, if you have a general customer support ticketing system, you might customize that for a particular company, for example, through an SDK. At the front end, the two things that I've seen to add to this SDKs is some sort of a feature API. So when you have a particular micro front end, for example, you might abstract the API of that front end over here so that you can allow the navigation system to navigate from one micro front end to the other in a general way. Or you might have some general data layer that allows you to store, fetch, and cache domain data, as well as synchronize them to the backend, regardless of whether you use synchronous fetching or asynchronous fetching. So it gives you the ability to customize that. Moving on to the other big layer, which is the features. Features basically represent the company's product portfolio. It's basically the code that the majority of the users are interacting with directly. When you decide to design new features, you're thinking about what are the products and features we're selling to customers. So let's say we're selling them specifically a Shopify integration, an abandoned cart integration, or a ticketing system, like a specific ticketing system with an integration, let's say to Zendesk or something like that. Features typically is something that at least one of your apps needs to do. So one of your service might be a feature, or you might bundle also some features in multiple services. Typically, you want to build in customers things that customers want to buy. So to give you an example, so when we pivoted, we abandoned or deprecated our ticketing feature and switched over to our commerce features, right, in order to execute the Connectly.ai pivot. When designing features, you should assume specific product context and domain models, including database schemas and backend schemas, but you should not assume that those product contexts run in a specific application context. What does that mean in practice? It means that you should be able to, for example, run your UI product logic headless in a test environment, let's say, without the presentation layer, right? So I should be able to run everything else apart from the UI in that environment, if I so choose to. Or I should be able to create, let's say, a demo application that just has my feature and not every other bundled feature that we ship in our regular application. At the system level, this materializes mostly as product services, which is where the core of the business logic runs for the company. Those are product flows that are owned by specific product teams as you scale up. So you might have a customer support product, or you may have a marketing campaigns product that you sell to customers, or you might have a Shopify abandoned cart product that you sell to customers, and there are specific product teams responsible for managing those flows and coding those. Optionally, you might also see some presentation services that adapt the product data for specific client types. For example, you might have a lightweight a service in order to support mobile clients if you want, let's say, the data fetching to be different than the APIs that you use for your web client. At the backend repository, that usually looks like a service domain where each service gets its own directory. And then within there, you would see some of these standardized MVC structures where you have controllers, entities, gateways to access your downstream dependencies, repos if you're accessing the database directly, and mappers in order to map from downstream dependency models into your local domain model for the particular service. The package structure looks similar to the SDKs, but you also start seeing things like integration tests at this point, since there is a lot of product logic that needs to be tested end to end. Or you might see a demo package, for example, if you want to expose your particular service as a single deployable in order to test it locally, for example. And then at the front end, structure is similar, but one thing I found that is different is usually each of the front-end features also has a considerable amount of local state, which might be the UI state if you're, let's say, running through a wizard or something like that, and that needs to be managed a little bit separately. I also prefer to separate the presentation layer here through an API, because that allows me to test the features kind of like in a headless environment, which runs a lot faster as well, instead of having to also deal with the rendering layer of every application every time. Finally, the last layer is the application layer, which is essentially the company's deployable artifacts. So you usually have entire organizations and teams that own one of or more of these applications. DevOps are responsible for deploying and maintaining the reliability of these. When you're designing applications, you should be thinking, okay, what kind of binaries are we trying to deploy? What kind of artifacts do we need to store and push to our infrastructure? How are we going to do that? The responsibility of the application is to set up the context, so the basic environment, the configuration that this application is running into. So this is where what I mentioned before, as your code running in different environments, plays a big role here. And then the responsibility of the application is not to introduce new logic, but to mainly wire instances from all the other layers together, right? So wire the necessary tenets and provide that to the SDKs, instantiate the necessary SDKs and wire that into the, let's say, the RPC context, etc. At the system level, the things you should be concerned about is, what are the runtime platforms for its application? Is it a web application, Android application, iOS application? Is it running in a Lambda serverless environment on AWS or on a raw EC2? Am I going to be using Docker in order to package the application or not? So many options here. The hot debate between monoliths, or microservices. Actually, I find out that it only applies to this layer. It only affects this layer in order how to package your code. It should not affect how you structure your code in general. So you could have a monorepo monolith or a monorepo multi-service, and you can fire both of those from this same structure. Apart from that, the responsibility of the app layer is to also configure the application for the right environment. So if you are running your applications in different environments, like a beta environment, a canary environment, or a dev environment, or a local environment, the setup and the different configuration parameters should be expressed, loaded and wired up over here. At the backend layer, at the backend monorepo, that might look something like this. For example, at Connectly, we bundle all our services into one deployable, which is called the RPC service. So essentially, even though we have separated logically our gRPC services into multiple features, like I mentioned before, in the end, we bundle them all in a single binary. And then we also bundle all our async workers in a single binary as well. So that simplifies a lot the deployment for a startup and the overhead of that. Over at Facebook, where I used to work, they had this big web application, which essentially bundled all the controllers in one deployable as well, which was like several gigabytes big, essentially. So you can see that this type of structure can scale up and down depending on the DevOps investment that you put into it. Other types of architecture you might decide is to separate some of the services logically. So if you have, let's say, some business layer services that are dealing with business flows, you could separate those into separate services. So for example, the ticketing system could be represented as a business tickets deployable, or the customer support product could also be implemented as a product support deployable. So in the end, you might still have a basic app, general app in your environment, but now this app directory has to deal with a lot fewer things. So it's pretty clear that it only needs to wire things together and configure it for the appropriate environment, and it doesn't have to deal with the entire logic of the entire system. And then at the front end, that's the app layer is usually where you wire up all the customer and the platform specific logic. So you might differentiate different UI layer, let's say, depending on if you're using React or React Native for your web application. You might wire up the Android core dependencies if you're developing an Android application, or the Swift core dependencies if you're developing a Swift application. Overall, this structure should help you navigate the different uncertainties from a small startup to a large organization. By thinking about these different layers, you should be able to structure your code base in a much more manageable way. With that, I wanted to leave about 10 minutes to the end to answer any questions. So please use the Q&A function to do that. Let's see. Everything was super clear. Okay, I'm so glad. All right. Cool. If there are I'll leave it up, I guess, for a couple of minutes if somebody wants to ask something. But apart from that, thank you all for your attention, and I hope this was a useful talk and can help you navigate the challenges of building and scaling like a code base in your company. Okay, thank you, everyone. The rest of the talks.